Hello, this is Yaze. We are back with another video. In the last video, we have learned how to solve the system of linear equation with the help of Gauss elimination method. In this video, we are doing the same thing with a different method known as the Gauss Siedel method. This is an iterative technique to solve the system of linear equation. We will learn this technique with the help of the code, the Python code, and as well as with the notes. So without any further delay, let's get into it. Okay guys, as you can see, we are on our computer screen and we got a pre-solved question of our notes here on our screen. So first of all, as you can see, we got three equations. To solve the Gauss Siedel method, first of all, we need to check the values. So first of all, we will consider this value and we will check that if this value is greater than the sum of this other two values. So as you can see, this is 45. If we measure this, so we will get that it is greater than 2 plus 3, which is means 5. 45 is greater than 5, so the equation 1 is okay. Then we will go on the second equation where we consider the second value here, 22, and we will check that if this value is greater than the sum of this 2 and minus 3. So by checking that, we can get there that minus 22 is greater than minus 1, and so the equation 2 is also okay. And by checking the equation 3, we will continue with our question. So to check the equation 3, we will got here the third value, which is 20, and we have to check that this 20 is greater than the sum of this 5 and 6. So as you know that the sum of 5 and 1 it's equals to 6, so you can see here that this 20 is greater than the 6. So we have verified that these three equations are perfect to solve the Gauss Siedel method. So first of all, what we have to do here, we have to consider x1 equals to 58 minus 2x2 minus 3x3 upon 45. Actually, it is the same equation. We have converted the equation 1 by taking the x1 on the left hand side, and we are taking the other values to other side to solve this equation. So as you know, we will put x2 x3 equals to 0 to solve the first iteration. So we have put it the 0 and we will get the value which is 1.28. so that is the first value of the x1. That is the first value. Then to solve the value for the x2, we have to convert the equation to we need to just transfer all the values on the right hand side and keep the x2 on the left hand side. So we have done the same thing here, and we have put it the x1 equals to 1.8. We have determined that earlier in the first equation, so we can take that as in our solution. Okay, and we will consider x3 equals to 0. By solving this whole equation, we will get that x2 equals to 2.31. Then to solve the third equation for the x3, we will just keep x3 on the left hand side and we will transfer all the other values on the right hand side. Then we will put x1 equals to 1.28 and x2 equals to 2.31. Then we will get the answer for the x3, which is 2.91. That is the first iteration of our solution. As you know, we got here, so x1 equals to 1.28, x2 equals to 2.31, and x3 equals to 2.91. To solve the second iteration, we will just take the same value we have determined earlier, this same equation, but we will change the values. So before, on the first iteration, we have put it the x2 and x3 equals to 0. So now what we have to do, we already got the values of x2 and x3, so we will put this value in our equation. Then we will get the second iteration for the x1, which is 0.99. For the x2, we will carry the same equation, but we will change the values. So as you know that we have determined the x1 equals to 0.99, so we will carry that 0.99 here in this equation. Then we will consider x3 equals to 2.91. Then we will get the solution, which is equals to 2.0068. Then we got here x3. We will take the same equation as above and we will just change the values. So as we got the x1 equals 0.99 and x2 equals to 2.0068, so we will take this value, these two values, and put in this equation to get the value of x3, which is 3.0026. So as you can see here that we got the second iteration of our method also. So in the second iteration method we got x1 equals to 0.99 and with the and x2 equals to 2.0068, and the third, in the third like x3 we got the third value of the second iteration, which is 3.002216. So that's all on the notes. Let's see the code, Python code here. We have already written this code, so let me just explain you this code to you. First of all, we just got our first matrix here. We can consider that elements of the equation as the matrix. So this element, you can consider the elements on the left hand side of the equation 1, and the elements of this equation 2 on the left hand side is the second row, and third row equals to the elements on the left hand side of the equation 3. And the b, we got the constant always like on the right hand side. So as you can see that 3 is on the right hand side, so we will get 3 and 19 and 31. So let me just convert this value into the our question. So as you can see, the first value we got here, it's 45, then we got 2, and we got 3, and we got 2 here, 22, and minus 3. Then we got here 5, 1, and 20. And on the constant side, we got the first constant on the equation 1, which is equals to 58. Then we got the second constant, which is equals to 47, and the third one, it's equals to 67. So the first matrix is the elements present on the left hand side of the all the equation we got here, and the constant b equals to the matrix list equals to the list of the elements present on the right hand side of the all three equations, and it is the initial guess variable, like we will consider the before, like 0 iteration equals to 0 0 0. And we got the number of iteration here. You can put the number of iteration if you want 4, if you want 5 iterations, so you can just put the number here and you will get the respective iteration. Then on the last side we got here Gauss Siedel method, and we are parameterize this function with 4 entities: A, which is our main matrix, and B, which is constant matrix, and X, which is the initial guess for the value variables, and the last one is number of iteration, which is equals to 4. Then this function call out this whole function above here. So as you can see that the n value is a variable here, which is equals to the length of A, which means it is equals to the length of this matrix. And we got the first loop here, which is running with we have named it here it, and it will run from the range of the number of iteration. Like we have got 4 iterations, so it will run till the range of the 4. Then we got the second loop here, which is I in range n means the length of A, so it will run till the length of A. Okay, then we got another variable here, which is sum of value, which is equals to 0 on the initial basis. Then we got our third loop here, which is equals to j, equals, like it will run till the range of the n, and n is equals to the length of A, as you know. Then we got our first condition here, which is if j not equals to I, then run this equation, which is the sum. We are upgrading the sum value here. Then we got the third. Here is the equation, which is in this loop, so this command will run. Then we have the print command here. It will print the iteration value of the first iteration, second iteration, and third iteration. So just run this code here. So just run it. Okay, so we got our solution here. As you can see, let's match this solution with our first and second iteration. As you know, the first iteration of our value, you can see here. Let me just correct here. Okay. As you can see, the first iteration of our value is 1.28, and the second one is 2.31, and third one is 2.91, and third one is 2.91. And on the second iteration, as you can see, we got the same values here, as you can see. So that's all in this video. We got our code here, and we got our notes here. So that's all in this video. If you like this video, to make sure you subscribe the channel and like this video and share this video with your friends. We will see you in another video. Have a good day. Bye bye.
It's caught in the crossfire.